Hello everybody. This is day 2, or lesson 2 I should say, of our exploration of isosceles and equilateral triangles. And today we're going to focus on finding unknown angles in both isosceles and equilateral triangles. You're just going to need, for this lesson on the video, you're just going to need your textbook. We're going to be going through some of the problems and some different ones as well, on pages 62 to 63. I'm going to start with an equilateral triangle. So let's look at the board here. And if you remember from yesterday, equa means same, even, or equal, and lateral means sides. So an equilateral triangle literally has 3 equal sides. All sides are the same length. Now, what I want to show you that is used in geometry to indicate that triangle sides are equal in length are these little lines, cross lines. And you'll see cross lines on the sides that make up a shape, not just triangles, but other shapes that we'll explore later this year as we look at four-sided figures. But for right now, just know that anytime you see a cross line, that is an indication that every side with a cross line is equal. So when you see this, and you're not given the measurements of any of the angles or any of the sides, you can automatically know that that is an equilateral triangle. All 3 sides are equal. So let's take a look at what that means about the angles. I have cut out what is an equilateral triangle here and labeled it with angle C, angle A, and angle B. And I just want to show you that, of course, remember how when we folded an isosceles triangle, we noticed that the 2 opposite sides, or angles between the opposite sides, were equal. But in an equilateral triangle, you should notice that all of the angles are equal. I can do this with every angle, and all angles are equal. So that's a property of equilateral triangles, that not only are all the sides equal, but all of the angles of an equilateral triangle are equal. So if we mark the 3 angles here, and we know that they're all equal, can we figure out what their measurements will always be? Well, let's go back to the property of angles in a triangle. We know that all the angles in a triangle, no matter what size, shape, all the angles always equal, the sum of all those angles are 180 degrees. So if I have 3 equal angles that all add up to 180 degrees, how many degrees would each angle be? Well, hopefully you can do the math in your head. 180 divided by 3. And you should come up with 60 degrees. So that is a property of all equilateral triangles. All equilateral triangles have 3 equal sides and 3 equal angles, and the angles are always 60 degrees. That's pretty simple. All right, now let's move on to isosceles triangles. So I have some isosceles triangles up here on the board, and remembering from yesterday, iso means equal, sles means legs, and in an isosceles triangle you have 2 of the sides are equal. So if we're given these triangles here, we're asked to find, well, first of all, I'm going to put those cross lines on there. So let's look at this one first. So I'm given that these 2 sides, make that a little bit more straight, are equal. I'm told that by those crosshairs. And I've been given that this angle is 65 degrees. Could I find the other 2 angles? Let's name them. Maybe this is angle, maybe that was angle B, this is angle A, and this is angle C. So let's think back to the property that we learned about isosceles triangles yesterday. Remember the pink triangle? We learned that the 2 angles opposite the 2 sides are equal. So if angle B is 65 degrees, then so is angle A. So that's pretty convenient. If I'm given one angle between the two equal sides, then I know that the other angle opposite it is exactly the same. So could I find angle C? Well, I certainly could, because angle C is going to be equal to 180 degrees minus the sum of those, right? So 180 degrees minus 65 times 2, or 65 plus 65, whatever you want to do, it's the same. So angle C is equal to 180 degrees minus 130 degrees, which is 50 degrees. So that would be how you could find an unknown angle in an isosceles triangle. Let's look at this triangle. Okay, so I'm given these little cross lines, so I know that these two sides are equal. So that is an isosceles triangle. I can tell just by the crosshairs. So how would I find the other two angles? So again, let's label this X, Y, and maybe this one was angle Z. So notice that these are the two equal sides. This angle is 84 degrees. Now my property tells me that the angles within those two opposite sides are equal. So could I find that angle? Sure. Okay, so to find angle X and Y, we know that we can subtract the angle that is across from the unequal side there, subtract that from 180 degrees, and that's going to give me the total of X and Y together, which are equal. So I can then divide that by 2. So let's take a look. X and Y are going to be equal to 180 degrees minus 84 degrees, which is 96 degrees. That's X and Y together. Now, because X and Y are the angles opposite one another between these two equal sides, they are in fact equal. So to find angle X, which is equal to angle Y, I'm just going to take that total, 96, and divide it by 2. And that's going to give me 48 degrees. That's angle X, which of course is identically, equal to angle Y. So there's a way to find unknown angles in an isosceles triangle if you're given the measurement of the angle opposite the side that is not one of the equal sides. Next, I want us to look at a right triangle. So remember that a right triangle is a triangle with a 90-degree angle. And let's ask the question, can a right triangle be an isosceles triangle? And the answer is yes, it can. It's not all right triangles are isosceles triangles. Now this one is. This is an example of a right triangle that is also an isosceles triangle. So let's determine which of the two sides would be equal to one another in length here, and therefore the angles would be equal. Well, the side opposite the 90-degree angle cannot be one of the equal sides in a right triangle. It cannot. Therefore, these two sides are equal in length to one another. And I can add those little cross lines to show that. Now, could I calculate the value of these two angles here between these opposite equal sides? I certainly could. Remember thinking back to the properties of a right triangle. We know that in a right triangle, the other two angles must add up to 90 degrees as well, because 90 degrees plus 90 degrees is equal to 180 degrees. So it's pretty simple here to determine these angles. If this is an isosceles right triangle, I know that these two angles are merely equal to 90 degrees divided by 2, which is 45 degrees, because those angles are equal. So each of those are 45 degrees. So one other thing I want us to look at too is in your textbook on page 62, number 3. you are given a set of triangles, 3 different triangles labeled A, B, and C, and you're asked which of the following are isosceles triangles. Okay, thinking back to isosceles, 2 of the sides equal, and the 2 angles opposite those sides are equal. So can we determine which ones are isosceles triangles? Let's look at triangle A. You're given 2 of the 3 angles. One angle is 38 degrees. One angle is 27 degrees. Well, you can tell that when you add those up, you should get 65 degrees. And certainly, if you take 180 and you subtract 65 to get the other unknown angle, you know you're getting a number that's very different. So you have a triangle here with 3 different angles that are 3 different measurements. So none of them are equal. So therefore, that cannot be an isosceles triangle. Now, if you look at triangle B, you should instantly be able to tell that, yes, that is an isosceles triangle because I'm given that those 2 angles opposite one another are 30 degrees. So those sides must be equal. So check, triangle B is an isosceles triangle. Triangle C, is that an isosceles triangle? Well, we'd have to figure out the other unknown angle. If you add 75 plus 30, you should get 105. And to find the unknown angle, 180 minus 105 is 75. So these 2 angles are equal to one another. So these 2 sides must be equal. So check and yes, that angle, or triangle C, is an isosceles triangle. So this is the kind of practice you're going to be doing in your workbook today. So if you could turn to page 70 in your workbook, I'm just going to have you do page 70 today. And you're given 4 different triangles. And it says the following figures are not drawn to scale, which reminds me, that's a point I didn't make earlier that's perfect opportunity for me to make it now. Just because you observe a triangle and you think a couple of the sides look equal, you can't assume that they are equal. So you can only assume that they're equal if you see the crosshairs. That tells you that those sides are equal. But you can't just look at it and judge it to be equal. So these triangles in your workbook are not drawn to scale and have unknown angles. You are to find the unknown marked angles, like we did here together, and then you are to mark each isosceles triangle with a check. So you'll find as you do your calculations that when you find these unknown angles in the workbook, some of the triangles have 2 equal angles and are isosceles triangles. So you would just, put a check inside the ones that are in fact isosceles triangles. So it's as simple as that. You're finding an unknown angle. You're putting a check inside the triangles that are isosceles triangles. And please make sure, just showing you very quickly there, that you show your work, just like I've done here. You write out your steps for calculating your angles so that I can follow and it's nice and neat. And just complete page 70. And we'll check over it tomorrow and we'll work some more with measuring or finding unknown angles in isosceles and equilateral triangles.